Hi, this is Kevin Lobates, CEO of ChainFrog, and today I'm presenting a talk that I gave at the Helsinki blockchain um, conference back in November. So the title of the talk was What Can Blockchain Bring to IoT? Here I am, Dr. Kevin Lobates. And so let's start off with the question, what is IoT? And I asked a couple of engineers at an IoT networking company what they thought it was. And they said it's network-connected autonomous or semi-autonomous devices that communicate through a local network and can share information with each other. When I pressed them a bit further, they said, yes, and the devices have sensors on them so they can read what's going on in the world around them, and they have actuators that mean that they can take actions based on those readings or based on the readings of other IoT devices. So I thought, actually, you need to dig deeper than that in order to understand IoT. And so here's the question, what is IoT really? And what I've done here is I've divided it up into 6 sections. Section 1 contains the actual network connected devices, lightweight processors, low battery power consumption. They're connected through software, shown in section 2, that takes local action and then can communicate data or receive data from 3, which is a network gateway. And then section 4, we have a storage where data that those devices produce can be kept. Section 5 gives us analysis where the data can be interpreted. That might just be conventional data analysis, or you may use some fancy AI algorithm in order to interpret what's going on there. And finally, 6 is a presentation layer to human users, which allows them to see data, interpret it themselves, and maybe click on buttons in order to make the devices take action. So when we look at it like this, we can look at the big players in cloud IoT. And cloud IoT companies are particularly interested in sections 3, 4, and 5. That is the network gateway, storage, and analysis. And the big players in that field, as far as I can tell, are Microsoft, Google, and Amazon. So Microsoft has promised to spend $5 billion over the next 4 years on cloud IoT. Google recently, or actually not so recently now, bought Nest for $3.2 billion, and Amazon haven't been able to find much in the way of concrete numbers for them, but when you look at the amount that they've poured into cloud, one can only assume that cloud IoT is going to be equally important to them, and they do have an IoT offering. IBM just failed to make it onto this diagram. They've pledged about $3 billion towards cloud IoT, but so I guess they also count as a fairly moderate player in the space. However, there are a whole bunch of other companies that I kind of consider the also-rans. They've come late to the party. They're not putting the same kind of money in, maybe hundreds of millions rather than billions. And I'm thinking here of companies like Bosch, Cisco, Dell, Salesforce, SAP, ARM, HP, Accenture. Basically, any large tech company is talking about launching some kind of cloud IoT solution. The thing is, it's not simple, and there are a lot of big players already in the field, so it's going to be hard to compete. So let's look at how the cloud can monetize IoT. And the first thing you can see is the usual model of you have a device connected to a bunch of cloud servers, and that produces some money because you can charge rent for providing those services. And this is the traditional cloud computing model. The thing is that cloud computing is now facing the same kind of thing that any commoditized service does, which is that the margins are going down all the time. So it's a good return, but it's not a great return. However, the thing that really, in my opinion, will yield good profits for companies is monetization of the data, and that's what the second line here is showing. Basically, these devices are going to be producing an awful lot of data, and actually the data produced by your IoT fridge is probably more valuable than the fridge itself. So that's really where the focus is going to be in the future. Right. And the thing to consider about that is that when data storage and control is centralized and a company's in charge of it, then they're going to reap the full benefits of the value of that monetization of data. So now actually let's move on to blockchain itself. And what I've pulled out here are 4 features of interest to blockchain. in the cloud IoT space. The first one is that IoT to IoT transactions become possible. You can actually transfer value from one IoT device to another without a human or even a network intermediary. So that's the top of that square. Then on the left-hand side, we have direct intercommunication of devices. They can use a blockchain in order to signal to each other. Then at the bottom edge of the square, we have data provenance, which is all about who owns the data that the device produces, and is that device actually producing valid data, or has somebody stepped in and tried to forge it? And then finally, on the right-hand side of the square, we have IoT device identity registration, which is about provisioning. So let's look at those in turn. First one, tokens. What can they bring to cloud IoT, or to IoT in general? And here I've got an example of a smart meter. So you have an electricity meter. These are the first things that really have been rolled out en masse in the IoT world that you and I are familiar with. No longer do we need a meter man coming to read the meter. The meter can actually send its readings back to the electricity suppliers itself. Now, imagine if we can take that one step further, and the meter actually has the authority to make blockchain financial transactions. This would allow an owner of a meter to say, right, these are the conditions that I'm interested in. For example, I like green energy, but when my funds run down to this level, then I'm happy to switch to the cheapest supplier. And at night time, I want to switch from green to nuclear in any case. And then the meter can take those instructions, and it can actually autonomously basically bargain with the different electricity suppliers for the power that it's consuming and make the payments without a human having to intervene. And I find this kind of amusing because it takes us full circle back to the early days where you actually had to put a shilling in a meter in order for the meter to operate. So in this case, the meters are actually feeding shillings into the system themselves. Right. Next thing to look at is identity and provisioning. So when you're making IoT devices and they come online for the first time, they need to establish an identity, because what you do not want is for an IoT device to be impersonated by some 16-year-old in London or some hacker in Beijing or something like that. And we do this with provisioning and digital certificates. So at the moment, it's quite a computationally intensive process to run in a factory, and factories want to get these machines out the door as quickly as possible. They want to load everything onto them as quickly as possible. And also there are problems with factories in terms of security breaches. So with the blockchain, devices would be able to register themselves on the blockchain with their identity, and then subsequently they can sign transactions they perform with those identities, and we can verify that the device really is what it says it is. And in this diagram, we have a factory using a lightweight process to publish a secret on the blockchain and store it on the IoT device. And then later, when the IoT device boots up for the first time, it creates its own digital certificate and reveals the secret at the same time. So it's actually not the secret that the factory publishes, it's a hash of the secret. And then the device publishes a secret and a certificate. Now everybody knows that device is what it says it is. So I think there's a lot of potential for identity and provisioning in blockchain. I think it's one of the first areas where we may actually see some real activity. So this actually allows us to move forward towards a decentralized certificate authority. And this has particular use to IoT, which means that IoT devices don't have to be tied to a particular device manufacturer or device service provider. It'll allow us to say, right, I bought the hardware, now I want to move to a cheaper or more efficient or more reliable or more trustworthy value-added reseller or service provider. And similarly, it allows us to control the data from our IoT devices. We can actually put a price on them. So that's the first half of my talk, and there's a video on YouTube of the second half that follows this. Thank you.